Introduction to SCADA. Hi everyone, welcome to this video session. We will learn more about the SCADA system, even if you know nothing about SCADA. So if you have a basic knowledge of how the SCADA system works, watch this video because we will refresh your knowledge. So watch it till the end of this video, because you will be able to 1. Define what is SCADA. 2. Describe the functions of SCADA. 3. Describe how SCADA acquires data in the field devices. 4. List components of SCADA. 5. List different types of SCADA. 6. Describe future trends of SCADA. What is SCADA? Computers play a major role in our daily lives. Hardly a day passes without us interacting with one. Even the one you are watching this video on. The computer field, majorly software and hardware development, is growing at a rapid pace. But how can we incorporate this huge growth in improving our daily lives, such that the software and hardware worlds are fully integrated to achieve maximum efficiency? The world is changing to an information-based economy, such that everything is digitized. But how do we incorporate this digital information into the analog hardware world? How can we achieve this, you may ask? This is where SCADA comes into play. But first, what is SCADA? SCADA is a control system that regulates other control systems through a feedback loop. That's a lot of jargon, man. This example will illustrate it in a simple manner. Let's talk about a simple control system of a floating switch controlling a pump. Let's say when the tank is empty, the floating switch shifts its position to a closed state, normally closed NC. This will allow the current to pass and turn on the pump. It will pump the water until the floating switch changes its position. The changed position will change the state of the floating switch to open state, normally open NO. This will turn off electricity and water supply. So SCADA is basically a control system, but it incorporates computers and network data. With SCADA, we can achieve local and remote control of hardware elements. This can help enterprises to mitigate downtime and use data to make smart decisions. SCADA is used all over the world since the 1960s. But the acronym SCADA means Supervisory Control and Data Acquisition. This means 1. We can gather data to interact with or control field devices. 2. Record events logs. 3. Also, we can communicate with field devices. Or, we can also be able to present data in an elegant manner. So basically those were functions of SCADA. Let's check which industries use the SCADA systems. Who uses SCADA? SCADA systems range from simple systems to complex industrial systems. SCADA is heavily used in manufacturing industries to achieve automation. For example, like soda refilling plants are known to use SCADA to do the following tasks automatically. 1. Wash soda bottles. 2. Refill each soda bottle with a specified amount. 3. Package soda bottles with polythene covers. But many modern industries are using SCADA, for example. 1. The energy industry in power generation and distribution, for example, Kengen and Kenya Power. 2. Oil and gas. 3. Transportation, and here we have Kenya SGR. 4. Food and beverage. 5. Recycling. 6. And many others. Not only industrial processes can be digitized, but even home automation is possible. We will talk more about home automation later. Types of SCADA. 1. Monolithic systems. 2. Decentralized systems. 3. Networked systems. These are third-generation SCADA systems. As the title suggests, they are networked and have a communication infrastructure in place. 4. IoT or Internet of Things SCADA systems. This is the fourth generation of the SCADA system. This is where it interests me the most. With advancements in cloud computing such as Azure, Google Cloud, and AWS, you can now be able to host a server, a network, and databases. Basically, you can be able to host all your organization's network resources. These resources are stored in a centralized place where all users can access them through the internet. With advancements in cloud computing and algorithms, IoT SCADA system can achieve a lot of efficiencies not solved by previous generations. Also, another huge development in microcomputers is Arduino. This is a small computer that has I/O modules, RAM, clock generator, and program storage. But this is packaged in a single circuit board. This can serve as your RTU, we will talk about this later. And you can build yourself a DIY SCADA system at home. So combined with the internet, you can achieve a truly IoT system. Not only major industries can use the SCADA system, even homes. The basic components of SCADA. Let's check the basic components of SCADA are 1. Sensors and actuators. 2. PLC or RTU. 3. HMI or human-machine interface. Let's further define each component and explain it. First, let's start with 1. Sensors and actuators. These are field devices such as 1. Temperature sensors. 2. Relays. 3. Humidity sensors. They can either be digital or analog. They help us acquire data and to know the operation state of field devices. The analog ones mostly use electromagnetic properties to indicate their operation state. 2. RTU or PLCs. RTU is an acronym that stands for a remote terminal unit. It is usually deployed in the field. It is a microcontroller-based device that monitors, controls, and connects field devices. But basically, the functions of RTU and PLC are the same. The difference is RTU can be used in harsh environments. Also, programming PLCs require special programming skills such as ladder logic. But RTU can be programmed using simple web interfaces. You can also program it with C# language. Also, RTU wins over PLCs when it comes to power backup options. But PLCs are much cheaper compared to RTU. We have not outlined the basic components of RTU. We can do this on another day. But let's finish this video first. 3. Communication infrastructure. To enable us to remotely control field devices, we need to connect them physically with RTU so that we can be able to extract data and monitor their state. Also, we can be able to communicate with other SCADA systems and can do this with ease. With a communication network, we are able to network, extract, and transport data. After acquiring data on the field, we need to communicate this data. We can choose the following communication system for the job. That is 1. Optical fiber. 2. Satellite. 3. Radio waves. 4. HMI. HMI stands for human-machine interface. In most cases that I have seen, they have used a computer to interface with SCADA. This is not a complete or comprehensive SCADA system. With HMI, the operator is able to see information graphically. This gives the operator control, supervision, and complete field data. He can also store data with normal databases such as MySQL and Postgres for further usage. So that was a basic introduction to the SCADA system. I hope you achieved the objectives we laid down at the beginning. I did this video because it was a voluntary exercise asked by the Africa Star Company, which is to create a course on technical management. I felt like the SCADA topic will fit right, because it plays a huge role in SGR operation from power distribution to trains route scheduling. Also, this topic was not well implemented in Kenyan technical schools. Maybe now they have improved. In Kenya, there is only one school that is teaching relevant SCADA industrial skills. But the cost of joining is expensive to average Kenyans. Thank you for your time.